Yeah, so this is the intro meeting for eCTF. So we're going to go over course credits, start brainstorming our design, and talk about a little bit of what we've been doing over break, which isn't a ton, but we've done a couple things. So first off, I'm Jake. I am a SIGPwny admin. I've been the embedded co-lead for last 2 years, CS and a math major separately. And fun fact, I was actually rejected from UAC and I took a gap year. So
Hi guys, I'm Swetha. The slide is kind of outdated, but I'm admin now and an embedded lead in SIGPwny. I'm a junior in Comp, and a fun fact about me is I play the violin and used to be in the university orchestra.
Hello, I'm Nikhil. I'm also an admin, also a junior in computer science. Fun fact, I lived in Columbus last summer. I was actually doing like embedded security work, so you can ask me about that.
So this slide's also old. I didn't have a new fun fact, but I'm Krishnan. I'm also an admin now. So where'd you get this from? But yeah, I'm computer engineering, and I'm from Washington, D.C. Yes.
all right, so here's some of the announcements. The kickoff was over break last Wednesday. I think some of you were there. There are links here to the rules, which we'll talk about more, and to the actual boards that we'll be using in the competition. This is something that we'll probably also send an announcement on Discord for. There's individual registration that you'll need to do in order to compete in the competition. It'll allow you to join the chat with the organizers as well. So that's pretty important. You should fill that out. We'll send the form in the Discord. I guess I could send it now, actually, just so that so yeah, make sure to do individual registration so you can join and actually like legally compete for UAC. And we also have our own form. I think probably somebody filled out, I think there's like 10 responses, but we added a question for sub-team preference. There's going to be an attack and design sub-team. We'll talk about that more later. You can go back and edit your response if you've already submitted it, or you should fill it out again. I sent it out maybe a couple weeks ago in the announcements on Discord, so make sure to have a look at that.
Yeah, so in terms of our sub-team structure, like Jake said, we're going to do design and attack sub-teams mainly this semester because if you guys saw the rules, they kind of changed the way the scoring is going to be. So they don't give priority or that much weightage to first blood anymore. And our automation sub-team was mainly to get the first blood flags. But since we don't have that, we're prioritizing design and attack. So the design teams are going to work on our main submission for the design phase. And Jake will talk about the deadline for that later on. But even while the design phase is going on, we're going to have some attack sub teams that are kind of prepping our hardware and our strategies for when the attack phase starts. So what we're thinking currently is having two sub teams, a fault injection team and a side channel analysis team. So that's going to be our overall structure currently. And then, like Jake said, you can indicate your preference on the forum that's linked in Discord because we added a new question. And then based on that, we'll be releasing the assignments within the next week or so.
All right. Yes.
Yeah. So yeah, I guess this is just some like overview on the challenge this year. We'll do some like brainstorming later where you can look at the official rules, but just maybe to like help understand what's going on. The challenge this year is to develop I guess what Meyer calls a hardware security module. So that is the actual embedded device for which we are going to write the code. And what this device can do is that it can store and transfer files. And like the scenario that we've been given is that these files are for like a chip fabrication facility system thing. None of the functionality of the device actually has anything to do with like chip fabrication. It's just like arbitrary files, but you're just imagining there's like chip fabrication. Like the attack scenarios will kind of have some story around chip fabrication. This is the actual like hardware board that the HSMs are going to be running on. So this is a Texas Instruments. This is the like development board product ID. And so this is a microcontroller board. So like it contains a microcontroller chip, which is like the main like system on chip that contains the CPU, memory, and so on. So that is this thing here, and that is the MSPM, whatever that thing is. It's a ARM Cortex M0 CPU. So ARM is like a RISC architecture. Cortex-M is for microcontrollers, and M0 is like a very simple, low power, and also quite slow CPUs. I mean, the low power comes with like low performance. And yeah, so I guess for some overview of what this HSM needs to do, the HSM can store files. So file is just like some bytes, like it has no structure beyond that. And like the metadata associated with each file is that it has a group ID, so the files are kind of divided into different groups. It has a UUID, which is like a universally unique ID among all the groups and like all the files. It has a name and it has the actual file contents, like the file data. The HSM needs to, or I guess, yeah, before we get into this, so the HSM is going to be talking to like a host machine. So that like think of your PC as maybe the host machine. And it can also talk to another HSM. So there's like communication in two different ways. The HSM needs to be able to read files, like the host machine should be able to read files from the HSM, and also write files to the HSM with like certain restrictions based on permissions that we'll go into. And HSMs can also transfer files between each other. So like HSM-A can send a file to HSM-B. And of course, like this would not be a security challenge if there weren't any like restrictions on how this stuff can work. So we have permissions for reading, writing, and receiving per each HSM and per group. So this is kind of, I mean, you can think of this like your like Unix mode bits. Like if you look at like any file on your computer, it has some permissions for like who can read it, who can write it, who can like create or well not create, but you can do like read, write, execute for like different groups and users and so on. And then yeah, I guess each device also has a pin, so that protects some of these actions. I guess you might notice something funny, like this pin is 6 hex digits. So that's like 24 bits. Like, is that actually a very strong pin? Like, is 24 bits like a cryptographically like strong number of bits? Like, how easy is it to brute force, you think? And like this has been, I mean, it has to be 6 digits. Like MITRE has told us it has, like the organizer, this is one of the requirements. Like it has to be 6 digits. Like we cannot make it longer.
Well, the brute force is 6 to the 16, right? Or 16 to the 6? 6 to the 16.
Wait, what?
16
The brute
to
force.
6
Oh, 16 to the 6. Okay.
is the
Wait,
number.
why is it 16 to the 6?
Because 16
Because
for
hex is
each
16.
times 6.
Sure, yeah,
Yeah.
okay.
Right, so that's the brute
Yeah,
force.
that
I don't know how relatively
I mean,
large
that's-
is, but it seems small.
It's 2 to the 24.
2 to
so-
24. It's not very good.
Yeah.
I mean, like on a desktop machine, you can do that like pretty fast.
They tell you to run like if you're making a regular password, you need like many more digits than that.
Many more,
Like,
right,
there's
right.
26 letters. And
Sure.
also, so.
Yeah, and like, I mean, 24 bits of entropy is like not good. Like there are, I mean, so you might think that's like completely broken, right? Like, what is the purpose of a pin if it's so bad? And like you'll see, like there's some restrictions on, like timeouts you can do on the device that will maybe make it like actually give you some kind of security. Okay, and these are the security requirements. So I think they should not be very unintuitive. Like the first one is just saying that and like an HSM should not do anything that it does not have the permissions to do. Like if you don't have permissions if an HSM does not have permissions to write files of a certain group, it should not be possible for the attacker to issue a successful write command and like get a file of that group on the HSM. If you don't have read permissions, then you should not be able to read a file from the HSM. If you don't have receive permissions, then the HSM should receive a file from another HSM. So yeah, that's just to do with the permissions. Security requirement 2 is to do with the pin. So I mean, it's just saying that if an operation is pin protected, then an attacker who does not know the pin should not be able to carry out that operation. And like we've already seen that like the pin is in theory it's a weak pin, but due to some restrictions, like some things you can do from the device, you can make it work. And security requirements. So 3 is kind of interesting. So 3 is like, I mean, you might think 3 is like related to 1, or it's like I guess sub requirement of 1, but it's actually not, because 3 is saying that the HSM should be able to detect if a file is like corrupted. So like maybe an HSM has received permissions for some group. It should not successfully receive a file that has been corrupted. So like imagine you're connecting your like victim HSM to some malicious HSM. Like the malicious HSM tries to send over a corrupted file. And that's not really breaking requirement 1, right? Like if the victim HSM receives the file and it has received permissions to receive the file, it's not really breaking requirement 1. Because like there's no violation of permissions happening in this process. But it is breaking 3 because
How do you know if the file is corrupted?
yeah, so I mean that's what we have to do, right? Like we have to implement some cryptography or some mechanisms that will allow the HSM to detect if a file has corrupted. Okay.
Yeah, so this is kind of what we've been working on over break. So we designed custom boards. This is during last semester as well. But this will plug into the chip whisperer and it'll allow us to do power analysis and fault injection attacks. So yeah, we'll probably need to do another revision on these because unfortunately we did not anticipate exactly what the competition boards were doing. I feel like they sort of lied a little bit. They're like, they'll be very similar to the Launchpad boards, but then like the button is on a different pin and the LED is on a different pin too. So yeah, they kind of lied, but we'll need to fix the pinout to actually match the competition boards. But we can still do a lot of stuff with these. We can still do like power analysis on like the crypto algorithms using these. So we'll probably that's what the attack team will be focusing on a lot of like during the design phase. Also, we've been working on the HAL. HAL is the hardware abstraction layer. It's how we're going to write Rust code that actually controls the features in the microcontroller. In particular, the Embassy project already had a lot of this implemented, but what it did not have the true random number generator. This will allow us to securely generate random numbers because otherwise, like everything's deterministic. So, like, how do you do something random, for instance? Because we might need to randomize delays to deter certain types of attacks, that sort of thing. We wrote a TRNG driver, it got upstreamed into Embassy. There's a flash controller driver that they're also working on right now, and Embassy will probably help them with that. So yeah, that's what we need in order to be even able to implement this in Rust, like at any level. And then we're discussing like in the leads channel, but we'll probably put some of that like condensed somewhere else. It's actually useful about like some security measures. One common security measure, like if you've maybe seen this in some of our Pwn meetings, just a general SIGPwny, we have a stack canary. Rust compiler emits those. Basically, it's a value that gets placed on the stack so that if you have like a buffer overflow that's on the stack, if you blow through the stack canary and you modify its value, when the function goes to return, it'll fail and it'll enter like panic handler. So yeah, that was fairly easy to implement. It didn't take too long. So that works. We were discussing maybe more advanced mitigations for like control flow integrity to make sure you're returned to the right place, like with a shadow stack or something. These are more difficult and will probably require us modifying the compiler if we actually want to do these. So yeah, people are interested on that. I guess I don't know. You probably know more about how to do these things, but
Yeah, it's
yeah.
like Jake said, you need to like instrument or like modify the compiler or somehow patch the binary afterward. But like patching the binary is generally actually more error prone. So if like people are interested in compiler engineering design, then yeah, this might be something for you.
Yeah, or if you want to learn LLVM, I guess.
LLVM,
Yeah,
yeah.
that's what the Rust compiler backend is. So yeah, I mean we were talking about some stack canary stuff. I guess Levchenko will be here at 7 to talk a little bit more about this. We're going to be offering 2 hours of individual study credit. So basically, like very high level of what the syllabus is trying to accomplish is we'll give credit for contributing to our eCTF team and also completing some complementary assignments. They should cover, I mean, the goal is that they're giving you the skills to actually compete in the competition, but there's like a little bit more structured. So that's the reason why we have like what might seem like kind of redundant work is because it's supposed to be instructive. I could go to actually showing you the syllabus so that we can clarify things or maybe fix typos or things like numbers weren't adding up until like recently. So things like that. Yeah, I mean, so this is like kind of about eCTF. Hopefully you're in the Discord. If not, I guess let us know later. The first MP is going to just be, maybe I should increase the font a little bit here. So the first MP will be kind of implementing like a really like not a super sophisticated thing, but basically there's like a pin code that you have to enter, and there's like a side channel where the LED blinks to tell you what the pin code is, and you have to enter it. The idea is, and once we have the repo template, it'll probably kind of get at what we're trying to demonstrate. But it's demonstrating the Rust type state pattern and like interfacing with hardware. So reading the input over UART, and doing something within like parsing it. Like it shouldn't be like, the idea is that it hopefully isn't like eating up all your time. But it should get you like started with actually writing a very basic firmware in Rust on these boards. And hopefully we have enough boards for everybody who are in class. I think we have like 20 of them. So I guess if like turnout's like way too much, we can try to figure out something like board sharing or something, and we get more. But yeah, I mean, once you have this, we'll have a demo after the MP is due, basically just running through some like simple usage. Yeah, I guess, does this MP like make sense to people? This is like going to be due during the design phase, so that hopefully people are up to speed. Because I know that's sort of been like a bottleneck sometimes in the past, where it's like, I don't know Rust and I don't want to complete this like, advanced feature. So we're trying to get like ease people into it a little bit, because I mean, there's only so much like the very basic tasks to do for the overall team. So it's like getting everybody up to that base level is the goal. Okay. So yeah, now we're at the kind of optional. So like maybe if you have a bit more experience, this is sort of the track for you. The other track is a literature review, which we'll talk about later. So this track is actually implementing countermeasures against fault injection attacks. So there's this white paper that, I don't know, I linked at some point, but I'll like, we'll link this like properly and somewhere where it's easier to find. But basically it's like a list of countermeasures. Maybe I should like find the PDF, right? Yeah, like this is like an example of a mitigation pattern where instead of using like 0 and 1 for your Booleans, use these values, because they're a lot like, if one of the gates like switches a 0 to a 1, that's like more easy to accomplish through fault injection versus like having to flip all of the bits in order to transition this value into this value. So, like a very basic idea for this is that we just have like a protected Boolean type that we use in Rust that has like these kind of values that it uses for comparison rather than 0 and 1. And we use that in critical places. Yeah, I mean, there's other stuff, random delay. This one probably won't be assigned because it's not like too interesting. This one is kind of interesting, where like you compare like a value and its complement, bitwise complement, meaning flipping every 0 to 1, vice versa. So yeah, there's like probably a couple different ways that you could write a wrapper that does something like this in Rust. And that would be an example of how you'd complete this assignment, depending on which pattern you get assigned. I don't need to go through each of these because we'll tell you a bit more about them like when you get assigned them. But I just wanted to give perspective on what this might look like. Yeah, so you have to implement it in Rust. It has to match what the riskier pattern was. Has to be a general thing that we can actually apply to our design, not just like one case of it. This is kind of the hard part, which is making it not get optimized. We'll probably be working with you directly to make sure that this actually works, because it's quite difficult to get to work, because the compiler will, like, if you do something twice, it'll notice that you're doing it twice, and that's useless, right? Just do it once. So it'll get rid of that a lot of the time. So you have to use certain barriers to prevent the compiler from getting rid of that. And then in order to make sure that it actually worked, you should look at the assembly to make sure that if it was supposed to do it twice, the instruction is in the assembly output twice. And there's some tools for that. Yeah, and then submission is basically just a write-up going over this and the actual product itself, like the code. And then bonus points is if you can verify this in like some automated tool, particularly this rainbow tool, which is quite interesting. Basically, it'll simulate if it skips an instruction, does the wrong thing happen? If you can like have an automated verification, that would give you some bonus points. I guess depending on how good it is, we'll decide what like how many points it's worth. But yeah, this is sort of the grading. Then I guess because I just covered this option, I'll talk about the literature review. So some of these are coming up very soon, so that's why they're bolded. Bolded ones will give like some extra points because they're coming up so quickly. Basically, I guess maybe you want to talk about this because this
Sure.
is, yeah.
Yeah, so literature review replaces the hardware like fault injection mitigation MPD. Like the hope is that if you're like not as experienced with hardware attacks or like just hardware stuff
Or Rust as
or
well.
or Rust, then this might be like an interesting option because like you can learn about some of this stuff and then you can also teach us. Like I have not read most of these papers. I don't think any
I've
else.
read a few of them, but
Okay.
yeah.
But I mean, you will be like other people will learn, like you will learn, and then maybe we will also learn. So like the idea here is that we have selected some like interesting papers in either like crypto or well, I guess one of them is crypto, and then like the rest of them are I think all hardware attacks. Maybe some of them related to crypto. And the idea here is that you will sign up for like one of these slots. And then you will have to read the paper. You will have to make us like prepare a small like presentation on it, like maybe make some slides, and then talk about it for like 15 or 20 minutes. And then like we have some guidelines on what like format that should follow and like what you should do. But like the idea will be that you get to understand the paper deeply, and then other people also understand it. So the first one, like the first few are like not very, I guess, complicated or like hard to understand. The first one is just this encryption scheme called AEID that's like very standard now. I think this paper is probably the one that like introduced this name and like formalized it. So it's like interesting to learn about, and we will be using it most likely in our design. So it's good to know. And then there's like some kind of foundational side channel or like hardware fault injection papers. And then like some of the later ones are more I guess more cutting edge, more new, modern, and then like maybe also more interesting. Like for example, actually this one, Chris Fletcher used to be a professor here. So yeah, fun fact. But some of these are actually very cool. Like even if you don't sign up for the literature review, like I encourage you to maybe take a look at some of these if you find them interesting. And like they're like very relevant also to what we are doing. So like many of them are to do with like how to do more effective fault injection or side channel attacks.
Yeah, well, in particular, one of them is even covering something we used last year, which was the like protected implementation of ASCON. So this is like a symmetric cipher, and it prevents differential power analysis, first order differential power analysis, to extract the key. Yeah, and then some of these other ones are about attacks that we would like to perform. Like for instance, this if we can perform this, there's a good chance that we will like depending on how teams have implemented their stuff, like there's a good chance that we'll actually be able to compromise like some really high value teams. Because yeah, in the past, like Purdue, Carnegie Mellon have used Cha-Cha Cipher. So we can do differential power analysis against it. That would be quite powerful. And they did not use protected implementations. So then yeah, this is hardware attack MP. We would have a bunch of chip whisper nano boards. So hopefully, like a similar situation, I think we have about 20 of those. We'll have various challenges where there'll be like either fault injection vulnerability or side channel vulnerability. And you should use like some script to extract the flag. There won't be a demo because a lot of the time these challenges just take like, even once you have the correct script, it might take a while to actually execute correctly. Like fault injection, you might need some thousands of attempts. Power analysis attacks, you need thousands of traces. So, you know, once you have the script, it would not be time effective for us to actually just watch it execute. But, you know, if you could extract the flag and give us like a reasonable script, then that's the grading criteria. Yeah, I guess as far as this first MP, we should have like in the coming days some like repo template. So yeah.
I guess it's worth saying like at least the first MP like it should not be very hard. It should not take a lot of time. I think we expected it to take like maybe a few hours.
Well, yeah, I mean, it depends how much experience you have. Like
Right.
PRs, if you're experienced, we're hoping at like a ceiling of like probably like 7 hours, something like that. I don't know. At most, but that's like a ceiling, hopefully. If it's not working out, let us know. Like we can try to maybe I don't know, we can figure out why it's taking too long, but yeah. I guess yeah, I mean that pretty much covers it. I don't know, there's also like actually working on eCTF, the like core stuff. The attendance is expected at the sub-team meetings. I guess let us know like if there are reasons or whatever. Like you can let us know and we can excuse absences. But the main point is that we want people actively engaged. And that's also measured through writing documentation and pull requests. So yeah. Also, the syllabus, if you'd like to reference it later, is announced on the Discord. It's also should be on the slides since we put those up. So. All right. Yeah, so I guess this is now time for brainstorming. We should probably pull up the rules now and
So, maybe pull up the rules if you have like a laptop or something.
yeah, probably individually. You also look through the rules and ask questions about like what makes sense, what doesn't. I will say
eCTF.murder.org.
at least my first go through, I had questions, so I think yeah, it's not like everything's I don't think everything's immediately clear. Maybe it is to you, I'm not sure.
It's also long, so
Yeah, feel free to take some time. Maybe after like 10 minutes of people looking through, we can start talking about maybe some approaches or attacks that we have in mind. I think there are subtle ways to get this wrong, that probably a lot of teams will make. So we could talk about this as well.
I guess like maybe one thing I'll say is like as you're looking at the security requirements or like tank flag scenarios, I think it's useful to think about like two kinds of attacker models. So one attacker model is that the attacker does not like break anything on the device at like a hardware level. Like they don't do any hardware sanction or like hardware fault detection. Like maybe they don't even do like buffer overflows or things like that. So like the only way they can interact with the design is through like all the cryptography. So like one area of attacks is just attacking the crypto. Nothing to do with hardware. And like it's possible that teams might mess up their design in ways that allow that. Like we have had teams, like it sounds unbelievable, but we have had teams in the past that will like hardcode all of their encryption keys, or like all of their cryptographic keys, in such a way that like every team can see that. Like you don't worry about that.
Yeah, like in the source code. And
Yeah.
the source code is given to other teams, so we shouldn't put secrets there.
But so I mean that's one like class of attacks, and then the other class of attacks, which is like specific to embedded systems, or at least systems where the attacker has some physical access, is all the hardware fault injection stuff. So like the model that at least we have been thinking about is that the attacker just controls the device completely. Because in theory, with fault injection, like you can just get any arbitrary code execution, and TMU pretty much had that last year. So like that's a maybe very extreme assumption. That you can also try to think about some more restricted abilities that the attacker might have with the device. I think that's yeah, and then there's like clone attacks, which like
Yeah, like buffer overflows.
buffer overflows, but like a lot of teams use Rust now. So it's like I guess I think it's harder to do those. I mean, I don't think last year we had very many of those. We had
I
a
think there
few.
were some, yeah.
Yeah.
There's some crypto mistakes. I think that was fairly common. Yeah, I mean, just historically, there have been actually a lot of buffer overflows. 2 years ago, there was in the reference design, this is maybe something else that people should take a look at. The reference design is designed to have, it's a kind of backdoored in a way. Like they have vulnerabilities that are somewhat subtle. 2 years ago, there's one that was so subtle that I think probably the majority of teams didn't fix it. They just used the I2C driver that was in there, and it was vulnerable to buffer overflow. So that was basically the 3 teams that found it just got like all the points and everybody else didn't. So that was a year because there wasn't much else going on besides that vulnerability. So yeah,
Last year was
all
also
the categories of vulnerabilities exist.
and like last year was also interesting because like crypto was very overpowered in the sense that with the right crypto you could just make the design completely unbreakable. Like the attacker had like no chance. Unless they like break AES or something. They just have no chance. I mean this year we can like we are confident like that is not the case. So like, hardware attacks are actually more powerful.
Because I don't know, you could go through this, but probably people should mostly look at stuff on their own. I'd imagine they'd probably be more productive.
Yeah, and then like hopefully Kirill, Professor Levchenko will be here at 7.
Yeah. Yeah, and also if people are interested in the boards, I guess we could pass a couple of these around. The microcontroller isn't populated, because we'll have to order that separately. But
That fulfills all the security requirements. I mean,
just none of the functional requirements.
here's my board. That's a block. Pretty secure.
Yeah, this is the board that will be going into the chip whisper for hardware attack development. And it uses the same microcontroller footprint as the attack boards that MITRE will give us. So the idea is that we could transplant the chip off of the attack board that they give us and put it onto there. I guess, yeah, for those who haven't completed eCTF, which most of you, the attack boards are, they have a particular firmware. When the organizers give us other teams' firmware, they'll give us an encrypted image. And only their secure bootloader, which is on those couple boards that they give us, is able to decrypt the firmware image and flash it onto the device. So that's why we would need to transplant the chip, because only those chips have the like MITRE secure firmware on it that would allow us to use people's actual production firmwares.
What do they mean by pin protected for like all these commands?
Yeah.
I guess if you so like we said previously that like each board device it has a pin.
Yeah.
And so for some of the commands, if it's pin protected, that means that
Oh, like pin number.
Yes.
Oh, I thought they meant like
not
board
a
pin.
physical pin.
Yeah.
Yeah.
Like it'll prompt you to.
Yeah.
Yeah, like many of the commands require the pin in order to.
Equivalent to password.
Mhm.
Are they doing a bug bounty this year or no?
Yeah, they are. That's actually something I wanted to test. I'm assuming it actually does work, but I was just surprised that an 8K file can be read over UART and flashed within a second. That to me seems or at least questionable on these boards.
Well, maybe you can like flash it and read. Like
Yeah, like
flash like
backward.
pages of
Is that what they're doing though? I would be surprised. That sounds a little sophisticated.
Yeah.
Maybe they're doing that. I don't really believe that, honestly. I guess I could look at the design, right? Where's the what is the repo for the insecure design?
Is it not linked in the?
Probably is. Let's just go back.
Yeah, just go
Where's the design? Okay, which
Getting
page?
started, maybe?
Okay, probably.
You're looking for the reference?
Reference, yeah. Is this?
Yeah.
Okay, there we go. After like 5 clicks. I know this is the wrong thing.
What they did.
Where's right? Yeah, here. Right file. Okay, that's conventional. Where's No, I mean this is just yeah, this is just doing it. Yeah. All right, we should see if that actually completes within 1 second for an 8K file, because I don't totally believe that. Because it like even at baud at the normal your baud rate, it actually takes half a second to transfer the files. So that's just half a
What
second.
is the plus the
Right, I think that's
Why?
I don't know, maybe I should.
you like actually tried booting this one?
No, I haven't. I don't want to use their bootloader because it doesn't work well on the. Because the button, like I can't even press the button on the launchpad boards because it's on a different pin. You have to use like a wire to like tap the pin in order to enter the bootloader. So I don't want to use their bootloader on the launchpad boards. Once we have the actual boards with Shankar, we can boot on that, right?
No.
All right, where's the?
I'm not gonna take it with me.
Okay, where's the tab? They don't have an icon, so I don't know where. Do they have a?
Okay.
Wait, where did I have the rules open? My chill. All right, whatever. Sure.
But I really don't think it's hard. It's like giving a dummy repo and then saying, do this with. Yeah, so the dummy repo is just like all the firmware bits and pieces. And you're just doing.
Ask them. I assume it's just like, hey, write this function.
Yeah.
Well, not necessarily.
And that uses the read pin.
And like if
Or read
you buy,
signal.
if they buy the raw, just buying the wrong thing. But if they buy.
I just feel like it's a bad idea.
Those same people
to
can
do
still
all
buy
this
just
on 3.9
3.9
and 3.2 and 225.
Then you additionally
that's
have
all
raw
raw.
extra out in case somebody wants to buy raw.
It's fair.
True.
But in 2 semesters.
I mean, you don't have to take.
Yeah, I'm like just.
Yeah, I'm trying to do this like
Run out of jolly.
I mean, it doesn't.
The like spark is all.
And well, yeah, I can dig it. These.
A cube we love that.
These
Yeah.
374 in math.
The functional program.
I don't remember what these
Do
are.
you apply?
395.
Probably not. For being one.
You know that guy is like so much potential and does nothing.
I mean, he interviewed at Jade Street.
And then CS4 was it.
Well, sure. But
Yeah, that was
I mean,
not as bad.
sure.
It won't be as bad as fucking.
I mean, I didn't know,
395,
so.
Wait, why not?
What
And
I had
UC4 way, that's
secondary
a
school, right? And like I.
Is there any time after the initial build where the HSM's provision will be changed?
Yeah.
I don't believe that's possible.
So we don't,
Yeah, I also don't
there won't be something that's like, man, now make the HSM have read permissions for this one, or write permissions for this. We don't want-
Yeah, there's no way to mutate the permissions. Right. So the permissions are fixed at like build time for the HSM.
Yeah, that actually
Well,
does.
but how are they stored? Because like, they have to be stored somewhere, right?
So that's up to you how they're stored.
Yeah.
Okay,
so
like,
when
It's
you-
given to you in the script that you write that builds the thing.
Yeah, it's like the firmware will of course contain some information pursuant
Yeah.
to permissions, but
It's just like
that's
your secret
decided by
code.
you when you build it.
So we can just store it some way that isn't,
Provided in this, in the
directly there.
detailed specs, it has this like permission strings thing.
Sure.
Yeah, I assume this is how we're.
Yeah, well, I mean,
No,
That's
because we
another
can
different-
do something which
yeah,
which
I'm
turns
imagining-
into the permission string, or like can be verified using the permission string, because we don't want to use the strings.
I mean, you can just store that in the device, right? But I mean, you probably want to have, and it's okay to store that in the device because the attacker knows the permissions. Like that's not secret. Like what permissions the device has, not secret. But you might want to store some additional stuff to like actually enforce the permissions.
Yeah.
Yeah, like for instance, maybe read corresponds to an encryption key or something.
And also this means that the groups are fixed at the start. So like you won't add a new file group, which is pretty.
That's good, yeah.
And the groups are actually fixed like at the time the deployment is created.
So there's just a group 1, 2, 3 to 8 or something.
You can have as many as you want, I think.
I think it's limited to like 32.
Yeah, I think that's something.
What do you mean by the groups are fixed? Are like the members of the groups?
Like which file groups you have are fixed.
Like
So you can't add a new file group. You can't add a file that says I'm in group blah when that group wasn't given to you at the start with the permission in your creation.
well, so the permissions are different. So the groups are fixed.
Permissions are assigned to groups.
Wait, no,
Yes,
each
but
file
the-
only has one group.
Yes, but the groups are fixed when the deployment is created.
Correct.
So that is before any HSMs are built. And then the permissions are like per HSM.
Yes.
So the permissions are not fixed at deployment creation times. Like you cannot provision some keys like once and for all for every HSM, like when there's
Oh,
time
you won't
created.
know what other HSMs have as their permission is what you're saying, right?
Right. I mean, you have no global view of all the
Correct.
HSMs in the beginning.
But it's still in that one HSM's build system, you know what its permission.
You know where its permissions are, you know all the global like information. Yeah.
But since each file has its own group, that means that technically the only thing an HSM has to know about are its groups. It doesn't need to care about any external groups as long as they are its group.
Sure.
So
Wait, that's incorrect. Because you need to, before you send a file, you need to know the.
Well, but how will you get the file?
no, it's with a malicious group. Oh, wait.
Well,
What's your question?
if you need to be able to send a file, like you need to get it somehow.
Okay,
You need to know
yeah.
the other HSM's permission
Right,
before you
malicious.
send the file.
Yeah. So you need to know all the groups.
Yeah, there are two ways to get a file onto the device, which is transfer or write. So like C and W.
Well, I don't agree that you need to know all the groups.
You don't need to know all, it's just like when you have to send a file, you need to make sure that the HSM is able to.
Okay, sure.
Sure.
But besides that, you don't need to know another HSM.
So you need to have a ways so that you know any specific group exists or not, even if you don't know all the groups that exist.
I don't think that is true either, because like on an HSM, if you're sending a file, like that file exists already on your on the sender. So the file must have gotten onto the sender in some way. So the sender must have either write or receive permissions for that group.
Yeah.
For the files that have ended up on the sender. So like the sender would have information about that group from the fact that it has those permissions.
Oh, so the HSM has received permissions for every single group.
No. So it depends per group. So you can have an
Or-
HSM that cannot receive certain files.
Oh, yes, okay.
Or you can have an HSM that can neither receive nor write certain files. And like in that case, it's pretty much as if that group does not exist on that HSM.
Right.
Because you like there's no
But
sense
like
of
it
reading.
will say yes, no for every single. Yes. or no.
Yes, every group has a read, write, and receive.
Okay, yeah.
Yeah, those are in this scenario, those are given as like the RW and C bits. So you might only have C, you might have R and C.
Like if an HSM does not have any permissions for a particular group, like there's no reason to store any information about even the existence of that group.
And it'll just like see it's the group that it doesn't have and then reject it.
Yeah.
And then we can store files in any way, if I'm reading this right.
So there's actually two parts to it. So there's the like file allocation table, which is like the index structure. And the structure of that is fixed in the rules. So we don't control that because the MITRE secure bootloader parses or uses that information to generate some like digest of files. So this we cannot actually wait. This file size.
But
Oh,
the index.
sorry. Where's the
A little bit.
Just go
oh.
up.
There we go.
Yeah.
Yeah. So this table we cannot change the format of. But we can store the contents of the file at like a little bit.
Sure.
And like we can, like Min was actually suggesting, like we can also just make a mirror table to this if we want. But like whether that helps us or not is weird. But this table has to exist basically for each file. And like the important thing in this table is this UUID, because the UUID is like in some sense how the it's like actually like a secret-ish piece of information about the file. Like the attacker should not be able to get the UUID of the file that they don't have the right permissions to read. And you'll see one of the flags actually it relies like entirely on the UUID. Like the contents don't even matter.
Well, the UUID has to be populated into this table.
Into this, yeah. But like the steel design, like you can like it will not check the contents.
Right. Yeah. I guess the way that you get the steel design flag, which I could show in a second, is it will read this like the UUID and like I guess the length maybe. And it will produce the flag if those are in the table essentially. The steel design flag is if you get either of these design files onto the technician, the Spider secure bootloader will output a hash based on the metadata, which would be that UUID. So basically, if you manage to get that UUID populated into the table on this board, and then use the secure bootloader to read the metadata in that table, then you get the flag. So it's like a little bit convoluted, but yeah, I don't know. I guess it's probably the only way to do this, but it's kind of weird because you're not interacting to get the flag. You're not interacting with their firmware anymore. You're interacting with the bootloader because the bootloader is reading something that their firmware wrote.
So where is this table stored normally?
Yeah, that has to be in a particular address. Let me find it. Oh, I don't say this isn't it.
The table was for each file.
Yeah, so yeah, I guess you could consider this like if a table like this might be a row, this entry, and then you could have several rows. The layout is that this file allocation table is at this address in Flash. And then yeah, like it's indexed. Like that's what the notion of I think you'll see it come up a couple times as a slot, and that's what this is referring to is the entry in this file allocation table. So basically, it's just like an array of like entries of this format.
Okay, but there's multiple entries. They're not all at that address, is what I'm.
No, yeah, it's like sequential, yeah.
Yeah, no, it's just an array of that table.
Yeah.
But I mean, you can't just have access to this file allocation table as an attacker, because otherwise you could just take the UUID, whatever you wanted, right?
Yeah.
Stored in this file allocation table.
I mean, technically, I don't think the UAD is totally sufficient. It probably should
But
be
the
protected.
for steal does not.
Well, you have to place the
You have to place
UUID
this-
into
you
this
have
location.
Control on both.
Yeah, if you have write control on this, that's so bad. That's like a problem. Like you're kind of done because just writing the correct metadata and then using the secure bootloader will give you the flags. That you have to protect this writing to the file.
So do you need to have something other than just knowing the metadata in order to get the flag?
Which flag?
The
steal
design?
Yeah. You need to have the metadata placed into the file allocation table.
So you need to be able to modify the defense.
Yeah, because like what needs to happen is that the file exists on one HSM, or it needs to wind up on another HSM. Well, the file, not the file, but just the metadata needs to wind up on another HSM. Like it's sufficient just for the metadata.
So the like the conceptual goal of the flag is you move the metadata from one HSM to the other HSM.
Correct.
That's the
Correct.
Yeah.
And the other HSM does not have receive permissions, obviously.
okay.
Otherwise, yeah, you
Yeah,
would
Doesn't
be
have
allowed
any
to do
permissions, it
that.
doesn't do anything.
I mean, then
That
it's not.
makes
I
sense.
mean, then it's like intended for it to be moved. That's
Yeah,
not security.
yeah, that makes sense. I was just confused because I just heard like obtain the metadata of the file. Well, if you have the file.
Well, but it is also interesting that when you read a file, it does not give you the metadata, or it does not give you the UUID. Like I was actually confused about this. So reading a file only gives you like the group and the contents, I think.
Wait, so but if
No.
you have the file, how can you?
So
Where's the metadata?
if you can read the file, you can run that eCTF tools command that gives you the hash, which is basically equivalent to
Wait, but the hash needs
I
to.
think the hash is device specific. Like the secure bootloader is doing something with the specific device that it's been flashed to.
If the metadata is
It's
not
probably like firmware specific.
Firmware specific, probably, yeah.
And maybe it takes like the hash of the firmware and like puts that, combines that into the hash of the.
Yeah. Oh, probably can't do that exactly because you could self-modify. But yeah, it's probably doing something. Like maybe during the flashing process, it gets some special bootloader only page that it does something in.
I mean, maybe it fills the hash of the firmware.
Yeah, at that stage, probably, yeah. But yeah, basically, yeah, these design files, you don't have access to these HSMs, like you don't have the pin.
Yeah.
You only have the pin for this. That's the main thing.
Wait,
not
so
7.
he's coming at 7.
Yeah, it's not 7, right? Yeah, so that's the steal is getting the oh.
But do you want to like talk about? I mean, we are done for.
Hey guys, my name is Professor Levchenko. I'm a professor at ECE. I'm the official grown-up who gets to sign off on all the cool stuff you do. I don't actually do anything. It's the team lead and of course you. However, I'm very excited to be a part of this because this is a very cool thing. The eCTF group routinely places in the top 3, I think, right? Last time, what was the?
I think we had like the last time, yeah.
Well, so
The years
number,
prior we had that.
number 2, I know there's some doping shit going on. So anyway, very proud of you, especially since we have not had a CTF team at least 10 years ago, as far as I know, and certainly not this. So it's very exciting to see hardware representation. If you want to come talk to me, please do. I think Swetha came and talked to me occasionally, but then stopped. Can I do a quick thing? Who's from CS at ECE? Wow, interesting. Well, that's good. I hope that, but I mean, takes all kinds. Okay, anything else I need to say?
I guess.
Oh, what's your name?
Oh, Jake.
Jake, hey Jake, I'm thrilled. Nice to meet you. And also, SIGPwny is really cool. Very excited about that. You guys are doing great things. You're the future. All right.
Need them on course policy.
Right.
Oh, yeah.
Registration.
Registration.
Should we collect all the forms and then send them to you?
Yes.
Okay.
So the plan is you'll collect all the forms. It is a 2-hour. You're doing the 2-hour option. So there'll be official syllabus. There will be expectations for how you get a grade for these 2 hours, and it will be a grade. I will give C's. So, I guess don't sign up if you don't want to do the work and you don't want to see. But if you get an A in this, it's a big deal. And I think actually I can tell them I'm giving course credit for it. They know they encourage MITRE. Encourages universities to give course credit for it. So I think we're jail to speak.
Yeah. Oh,
For our time.
yeah, there's some in there.
Okay.
Yeah.
All right, guys. I love hardware stuff. This is really cool. So they'll tell you what to do, and then at the end of the semester, I will sign off on your grade as determined by the rubric. Goal is to be very transparent and clear how your grade is assigned.
And
Yeah.
we talked about the syllabus also.
Great. I'll tell you a little bit myself. I do some hardware research. Nikhil's working with me on some hardware, software-y thing. Hardware is very cool, and it's one of the hardware security and embedded system security, something that is not as well developed as the normal security for the web security or server, mobile security even. So it's something that is harder to get into because you really have to understand both sides of things. But it's also very important. You're in a unique position at this great university to do that. Yeah, right? Do great things.
Thank you.
Cool.
All right. So now you know who you'll be getting course credit from. Yeah, I guess should we maybe talk about the various attack scenarios to make sure people understand that? Because I think usually those are the most important requirements to understand.
Yeah, and also the attack scenarios are more specific than the security requirements. Like you could have a design that none of the attack scenarios are applicable, but it does not meet the security requirements completely.
Yeah, I think the security requirements are much stricter than the attack scenarios this year. I repeatedly looking at the security requirements and comparing them to the attack scenarios, I thought of so many ways you could fail on the security requirements and pass everything. So yeah, I mean, Steele, we talked about that in some detail. The idea is that at a high level, get a file from machines that you don't have the pin from onto an HSM that you do.
You should talk about the setup.
Oh, sure. So yeah, there are 3 HSMs. One of them you have the pin. The other 2 you do not. This one is details are still a little fuzzy on with how this is going to work, but there's a remote HSM that's hosted on MITRE's infrastructure, and there'll be some. I think they've given more details. I haven't looked at it fully yet, but there'll be some way that you interface with this over the internet to communicate with your own HSM. And I guess you need like a UART adapter or something in order to put everything together, but
So does that mean that we also need to think about internet security?
hopefully not. I think this is like out of scope.
Like check mark.
Okay.
Yeah. Well, I mean, I guess it like in a way it doesn't totally matter because the idea is that the attacker has full control over this UART channel, right? So your protocol should be secure to whatever is going on over that UART channel. But yeah, basically this is like hosted somewhere and there'll be limited ways to interface with it. But that includes there's like the one line that goes between two HSMs, so that will be available over the internet. And the idea is that for the first one, oh yeah, then I guess this is like sort of yeah, you get the pin to the technician, not to the others. The photolitho machine, that's the remote one. Engineer is the one you don't have the pin. I guess that's the way that's the way I think of it. But yeah, the pin you have for the technician, these are firmwares that you can actually flash on your own boards. You have physical access. Management interface is you talking to like over USB. So there's yeah, the transfer interface that's between the two HSMs, that's the UART1, if you're thinking of it that way.
I think there's an interesting point for like the remote thing you don't have like full access to.
Yeah, and that was the thing I didn't read closely enough to know what exactly
It says
you
you
have.
cannot read or write, but you can transfer.
Yeah, like I think you'd start the transfer process. So that's I guess what they mean about the yellow, like some access. Yeah. So that's like communicate over USB to the host, but yeah, so that's sort of the setting up like for these 5 attack scenarios. The first one is there are 2 files, one on each machine. If you can transfer them, which means writing the metadata onto your technician, then that's a flag. Read means there is a file that will be preloaded onto the technician HSM. If you're able to get the contents, the flags in the file, then they'll give you points. The only HSM that has any permissions to do with the update is the technician, which has permissions to get it transferred onto, but not to read. And then the photolitho machine, I guess if you're able to transfer it onto here and read it, that would be a problem. That's why you don't have access to read from the management interface, because you could just transfer it here, read, and that would be trivial. So yeah. Redesign is again these files from this scenario. I actually don't really know why they listed them in this order. It seems kind of weird, but yeah, there's these 2 files again. If you can get the contents off of them, flag again. I mean, I guess in some sense, if yeah, I guess this would sort of be combining 2 things. Like if you could transfer it onto here and then also read the contents off, that would be, I guess, how you'd get both of those. But there's probably other ways that you could exploit it directly off of the engineer HSM to read. Because yeah, the only reason you can't read, even though this has permission, is you still have the pin. So if you got the pin somehow, then you have permission to read, so it should go through, right? Compromise is what was this? Oh yeah, basically if you could get an update file, and this is again where having the management interface matters for this remote machine, because you should be able to initiate a transfer onto this. If that update file is corrupted, the update file that's on here, and then you're able to corrupt that file, send it over to the remote machine, flag. If you're able to place particular backdoor into the file, so not just like corrupting it arbitrarily, but corrupting it in a specific way, and then transfer that over, that's also flag. That's it. Those are the attack scenarios. So security requirements seem a lot more strict than what this is testing. So you could probably think of a lot of ways not to meet the security requirements in full generality and not get any points lost. So I feel like it's like slightly worse than the past years, honestly, because past years it felt like these tests were a bit more rigorous. Like obviously there's probably some like contrived way that you could not pass the security requirements, but it seemed like it's doing a bit of a better job testing. So I guess good for us in a way, because it means less ways that we can get compromised. Like for instance, like the last 2 seem like almost the same, at least to me. It's like if you can do backdoor, you can I mean it's like automatically compromised machines. So they're both about corrupting the file. It's just like specific corruption versus targeted. So it seems like they're testing almost the same thing. So I don't know. It's should make it a little bit easier on us during design phase at least. And I guess I don't know, first time I looked through these, I didn't fully digest it. So it probably makes sense in like the coming weeks as we're actually having to work through our design. Speaking of the coming weeks, I should probably show like, I mean, I guess yeah, this doesn't exist. But so yeah, this Saturday we'll have another meeting where we'll actually be making core decisions about our design, hopefully. So be thinking of things. Oh, I guess totally unrelated to that. If people are planning on taking the class and want to do the extra credit, I think the original due date was today at Wednesday or sorry, today at midnight for the like draft design document. I don't know how far people have gone with that. I think we could probably give till like Friday though. I think that's fine because I mean this just started semester, so it's fine. We'll push that to Wednesday, or say Friday. And yeah, hopefully have it done by Friday though, because we need to talk about our actual eCTF design doc on the Saturday meeting. And yeah, also if you don't know about the draft doc, I don't know if we should form more groups. It's maybe too late. Sorry. It's only like a few extra credit points, so hopefully it's not too like devastating to your grade. There are definitely other ways to earn extra credit than just to get credit in general. So yeah, but yeah, this Saturday meeting, hopefully we should make a lot of core progress towards our design. Ideally, all right, so this is kind of like big picture view, but like end of February on Wednesday is handoff. So this is the first day we could submit our design. The longer we have our design submitted, the more points we accumulate defensively. So the way the scoring works is, basically each second, well, not each second, right? Like after, I don't know, several hours or whatever, you accumulate some points for each flag that has not been compromised by another team. Those are the defensive points. So it is almost always to your benefit to submit sooner, as long as you're not submitting something that's like less secure for that. Just reason being, you just accumulate more of those points. So yeah, ideally we will be submitting on that Wednesday. I think last year we submitted like only a few days after. That was our best performance. Usually we're like a week or two behind. Hopefully this year
Maybe a week or two. It was better than like it was less than a week.
I'm not sure.
It was like a few days.
Yeah, it was like 3 days.
No, last year was.
Yeah,
No, I'm
Like
talking
year
before
before.
this. Yeah. Yeah. Last year it was like only a few days, which was good. We should shoot for better, but that's okay. Weeks, we are actually significantly impacting our score. We submit weeks late. So let's shoot for having it done a few days before that. Hopefully that's a little bit easier to do because like I mentioned this briefly, but the embassy project has like a lot of the Rust stuff figured out for us. So it should be much less painful doing Rust development on these boards. I already have been doing some firmware dev in Rust. It's fairly painless. So yeah, ideally that friction is gone. So I mean, we're pretty much good to go to write this stuff. The only thing that's missing is the flash controller, which should be done in the next week or two, something like that. Yeah, hopefully like next week, Wednesday, our design doc should be done so we can actually get started. Like splitting up groups and assigning tasks. Ideally Saturday we get like the bulk of things done, and then we do like maybe like actually verifying that our design is correct and things throughout like the week till that Wednesday meeting. I guess I could put that on the next meeting stuff, but that next Wednesday is important. Yeah. Wait, that would be 20th. Um, okay. Yeah, I mean, I guess do we have more like structured content? Like not really, right? I guess let us know any questions. We'll put the instructions for the 397 individual study credit up. But we'll have a form to submit your completed form to. Basically, all you'll need to do, we'll provide you the description. So then you basically just need to fill out, I think it's just like your name and UIN or something like that. We'll give you the description for individual study. Yeah.
You mentioned like you updated the Google form.
Yeah.
So we need to like fill it again.
Yeah, you should be able to go back and edit your response if it's on the same Google account. We just added one more question. I was like, which sub-team would you like?
And maybe like for some context on the sub teams,
Can you go back to that?
design is probably good if like you like writing code, like software development.
Mhm. Attack will definitely be a lot more hardware heavy, so if you want to write code, definitely do design.
Yeah, tech I think this year will be like very heavily focused on hardware. So
Yeah, like if I don't know if this stuff looks cool, just probably attack. Yeah.
Did they change the first ones, like rules, like
the first part is
It's not, yeah, yeah.
like no more like 2A.
Purdue too.
Oh, yeah, Purdue too.
I think it's like mostly good, a little bit bad.
Well, there's still decay.
It's bad
There's
because
They're
still
all decay, but it's very slow.
Right.
Hey, Bill, that's what CMU was getting so far ahead.
Well, not yeah.
That was part of it.
And then
They were
their
also
design.
just getting, yeah, their design, but they're also just getting
Flat.
flat. They just
Yeah.
got all
A lot
every
more.
flag that was captured last year, they had captured.
I mean,
Right.
first,
So, like, yeah, that's pretty powerful stuff.
yeah. Personally, like I'm interested in making our design as good as possible because last year it was not good as possible. Like we lost a lot of points.
I would say there's a particular moment where we kind of had decided not to focus on some of the fault injection mitigation stuff to do it as well as we should have.
Yeah.
I don't plan on repeating that mistake. Because Carnegie Mellon said they put 200 man hours into doing an advanced fault injection attack against us. So like we need to be prepared for that. I
At least
guess.
like they said, we were the hardest team to do it.
Yeah, we had some mitigation, but I think we could have done more. Like we didn't even look at the assembly and stuff. Like there's like some low-hanging fruit there to improve our fault injection mitigation. So
Yeah.
I would say that should be probably the main focus of our, because I think 2 years now we've just lost due to fault injection.
Well, last year we lost to crypto.
Because of our key duration.
We didn't have it to treat.
Yeah.
Well, in a way,
The
yeah,
fault injection would have been like not significant. If we
but
had
that's how they did it though.
it is how they did it.
Yeah. So like, yeah, I guess, yeah, we lost because we didn't find the unbreakable crypto solution, but but there were other undefeated teams that hadn't gotten that either. So yeah, it's kind of, but like we need to be secure against fault injection because that seems to be the main way we're losing. 3 years ago, we lost because we screwed up the build and like reused a secret somewhere where we shouldn't. I don't think conceptually the build is simple enough this year that I don't think we'll repeat that kind of mistake. So yeah, I mean the main thing is just hardware attack.
Any questions? Questions, concerns? Any comments? Yeah.
But this is more a question about 390 or not really, not at first. First about the sub teams. So with like the lack of automation anymore, which sub team would you recommend more? Like for
I think
automation?
Like if you're interested in automation.
Yeah, that was my
if you want to do automation, then which sub team should you be on?
yeah,
Probably attack, right? Because the automation is
Yeah.
only for attacks.
sure.
Like the design has nothing to do with it. Oh, but on the other hand, like if you like writing code, then you should do design.
Yeah.
Like the automation was writing code.
Mhm.
For
Yeah.
the most part.
I mean, I don't know. Is there might still be some use, like if we have like extra bandwidth on the attack side.
But like
to
what
do.
automated attacks are we doing? I mean, we don't.
I mean, in a way, some of the stuff is like
If we
semi-automated.
find something
like,
that's like very
uh,
easy, we can easily automate.
I think
Yeah.
automation should look into like LLMs because like I think they can. So I mean, some things obviously they cannot do, but something like the team left their secrets in the source code, right? Like that's easy enough to LLM. can
You
do.
think an LLM will read the entire like code package and then figure out how to?
Sure.
No, what we do is we just grab secrets.
I mean, but like it's like an agent, like it can do tool calls or something. So like I think with the current power of LLMs, like that should be easy for them. at least easy to flag and then possibly even easy to explain.
We should just get an LLM with like an insane context window.
Oh, sorry, I need to turn on my laptop audio. What was that?
Oh, I said you should just either pay for an LLM or find like an open source one with an insane context window. So you can just look at a large amount of tokens at once.
I mean, I don't think it even necessarily needs to do that, right? Like it suffices for it to look at even files or sections individually. At least for like hard-coded keys. Like maybe for some other tech, it needs to have like a full like global view of everything. But and like so also last semester, actually the three of us and Ryan wrote this like paper on LLMs for hardware attacks, and like we never did anything with it. So like, if you want to read that paper, you can.
Read it with a grain of salt.
It's not pretty clear.
It's not
Like,
very-
like if you want to do automation, like that's another direction. There's also the like ledger rainbow stuff. Like if we don't know how to fault inject the design, like you can just throw it at like rainbow. Like rainbow, like the way I see it is there's like a fuzzer for like hardware attacks. Like it can test like just
I think
throw.
like a little more deterministic than that.
Well,
Because it's literally just going through each instruction.
that's like fuzz. Like fuzzing doesn't have to be random.
That's fair. Yeah.
I mean, it's like a very like well, not exhaustive, but it's like a very high throughput like testing for hardware attacks. And like maybe you can find something that we don't know about. So if like somebody wants to set up some like automation to do with like bring designs into Rainbow and like seeing what comes out, then it's maybe interesting. And I think there's definitely things to do for automation. It's just that it's maybe not like as critical.
It's not the highest priority.
Yeah. Like if you want to do it, you can do it.
Yeah.
For sure.
Yeah, I mean, I guess if you are interested, we could probably like if there's a lot of people who are interested in working on that, we could get a couple people together and do that. Honestly,
But like it won't be like a 6-7 person.
probably not. Yeah, I mean,
Yeah,
but, like we could
but
get like
it won't
several
go
people
team,
on
yeah.
that.
Yeah.
I think
Yeah.
like if there are people interested, yeah, we could get several people on that because I think
Yeah.
there are probably like even like very subtle like simple ways to get the security requirements wrong. Like I don't know, like we could just try like doing like read like we could literally just see like read without permission. Does it go through? Like stuff like that, right? Like we should probably have automated tests for that anyway. I don't think we'll work as hard on like the Slack bot scraping, like that side.
Yeah.
That stuff doesn't make any sense, but having test cases still makes sense.
But we don't want to work on automated flag submission because that's
No,
just
it doesn't.
yeah,
it
it
doesn't
doesn't do
test
anything.
anymore. Yeah.
I mean, I think the automated testing for hardware is probably pretty good. Like I don't think anybody does that currently.
Like what?
eCTF.
I mean, I assume they have some sort of automated tester.
Well, is anybody like doing like finding hardware attacks by any means other than like looking into the source code themselves?
Oh.
I don't
Yeah.
think anybody's doing that. Or we have not heard of anybody doing
An eCTF? No.
Yeah, in
I don't think
eCTF.
so,
And like I think it's interesting to see like I mean because like we would also probably want to run it against our own design. Like useful also.
Yeah, Rainbow defensive testing on our side is that's something maybe we should have put in here, honestly, like as an explicit thing. I guess once we split up people in design phase, or like once we have our design figured out, we could split some people onto that. But yeah,
Plus,
I mean,
once
like
we have that, like it's just free to use it on other people's.
yeah, because like the Ledger blog post literally talks about how they have like a little CI/CD system on GitHub where like you can write some test cases that just look like ordinary Rust test cases, and it just runs basically exhaustively checks if we skip any instruction here, do we get the wrong result out of the test case? So
It has to be emulated.
it is emulated. Yeah.
So do we have like a way to emulate this board?
I think we could write test cases that don't necessarily require like
Sure.
the HAL or something, right? We could try to track that away.
Yeah.
Because we could just give them the assembly. It's all they care about is the assembly.
Well,
I mean-
it's actually even easier because we could just write Rust test cases where it's like we call our Rust method and it will compile just that. It won't necessarily interface with the
Like
HAL.
hallucinate.
Well, we don't even need to do the HAL,
No,
but-
wait, sure.
right? Like I'm suggesting that we could try to avoid that for now, emulating the HAL. Although you can, like there's some things in Rainbow where you could like this register, we do certain things to emulate the UART driver, like whatever. But
I mean, we can only run like the business logic in the code.
well, we could emulate the hardware if we want to.
We can, but we don't maybe don't have
Maybe we shouldn't.
Yeah.
Maybe it's too complex, but yeah.
like after like read something, it will do a bunch of things and then like probably write something out. And like all of that stuff. Probably fine. Well, it might like read or write Flash. That's probably okay. Right?
Well, we need
Well,
to
maybe
emulate
it's
the flash
not.
control
Yeah,
registers. So we should just have ideally maybe like the business logic, we can like stub out the actual hardware implementations for now and just test the business logic.
Like I'm thinking, I mean, we can do this in our code, of course, but is there an easy way to do it like automated on other people's code?
Oh, that's what you mean. No, I think we need to emulate the peripherals. Maybe we should actually do that during design phase then.
Yeah.
Like
I mean, we can
write a UART driver that works with the emulation. Shouldn't be that hard actually, I'd
I
imagine.
mean, we just need to like intercept all the register
Yeah.
calls and handle them.
There's probably not, I mean, there's only a limited number of things you need to do there, right?
Sure.
Same with the flash controller. Those will probably be the two peripherals that most people care about. Maybe some GPIO, which is.
And I think there's like tools or like systems to do that. I mean, at least to help you do that
Yeah.
easily.
Mhm.
I think there's wait. How do you create a new tab? Wait, what browser?
You have that many tabs open?
I think this.
Classic.
Yeah, I think this might be like useful. I haven't used this, but I've like read about it in many papers. And I think like honestly it might even be like overkill, but it has some good features for emulating embedded systems.
What if we just gave like an LLM like PRM, like the page, like a few pages about how your driver works.
Yeah.
Like please emulate this in Python.
Real.
Like maybe it could probably get something that's at least
Yeah,
close
yeah.
to being right.
Yeah, I guess they have some like tutorial, but I think what we want to do can be done in this tool, but maybe it's like not even necessary to use
I
it.
think the Rainbow like Ledger docs had like an example.
I think they're
I could
using like
show.
unicorns, right?
Yeah. They had an example for how they did it.
Yeah, I guess you can do it in unicorn. Sure. Unicorn, yeah, okay, that's probably easier.
How did they?
You can like intercept some memories. It's very easy, like YAML.
Did they
Probably just have some hooks on memory.
seem that interesting? I don't know what these are, honestly.
Well, like I can believe how they do that. Like it's not hard. Like because unicorn only emulates the CPU, where it lets you hook out.
This is certainly doing something. I don't know what that is. What is E? E is, oh yeah, so it's doing some memory at least, right?
Right.
Okay, yeah, so they're doing something. I thought I saw like a more complete example on one of these.
Well, I can believe that it works. Like it's not.
Yeah.
And I can imagine how it would work.
Yeah, I wanted to produce it so that we could show people too, but maybe not.
Well, I can explain like my guess of how.
Yeah. I wanted the code, hopefully, but let's see.
We
I
just
don't know.
grab for unicorn in the repository. Okay. Yeah.
These aren't examples. This is
Wait, just imports.
I mean, Rainbow is built on top of Unicorn, so maybe
Well,
you
but
don't need
I mean,
to
if you
fix it.
emulate a hardware platform, you need to intercept like memory reads and writes.
Yeah, which is some
Which
of
you
these
can
are
do in Unicorn.
these are actually being done, right? At least it's writing some stuff here.
This is just writing, yeah, but
Yeah.
you can like hook. Well, try like grep hook underscore mem. That's the Unicorn function.
Yeah, it's doing something here. Oh, this is emulating an STM32. That's cool.
Okay, yeah.
How do I close it a little? All right. It's trolling me. All right, anyway. Yeah, okay, so it's emulating some peripherals here.
The memory map.
Okay, so yeah, we should probably do this. This looks cool. We should like instead of
Right,
STM32,
right.
it should be MSPM0.
Right.
And we can emulate some of the peripherals. All right, yeah, so that's like another design project if people are interested in that, like trying to emulate the few peripherals we need. Because it's probably just like realistically just like synchronous UART and flash controller
I guess
synchronous.
if anybody wants to do like this project, you can talk to me because I've done something very simple for.
That you can talk about?
I can.
Oh, okay.
So this is actually my research with Kirill.
Oh, okay,
For which
okay.
I've done something. So,
Hmm.
yeah, it's not hard like at all. Like I'm sure GPT can do it.
I'd rather not use that though.
Well, GP like you just need to like parse the like data sheet, like
Yeah.
figure out what all the registers do, and then just like implement it like that.
Yeah, I mean,
Yeah,
I'd
that's like
imagine-
something else.
Or Rust. I mean, Unicorn has Rust bindings.
Yeah.
But I mean, to be fair, what would be the point of you doing it in Rust other than faster?
Because it's in Rust.
I wrote in Rust, by the way. You know, that's basically it. But yeah, wait, let's see what it's doing, because it's doing something with the RNG. Yeah. So this is actually emulating the TRNG peripheral. This is something that we might want to look into. Like that's probably a peripheral I forgot about emulating. But we could do something like this. And it's pretty simple. It's basically just like, yeah, I think we actually might need to do a little bit more because the TRNG, I wrote the driver for that in Embassy, and there's like a lot of registers, that configuration registers, but we can probably mostly ignore it. We just need to like set the right bit so that it thinks we did the setup. Yeah. But yeah, I guess that's probably everything we can. Hopefully, yes. People who are in the class, work on your draft designs. We've extended that now. Make sure to do the form, like the MITRE form and the interest form that we put out.
Did we link the MITRE?
The MITRE is the one you
registration.
linked, and then the
Okay.
Yeah, both are linked here. I'll send maybe like a follow-up announcement, but yeah, come with design ideas for Saturday. That's probably the biggest thing because yeah, we need to get started on design. Like kickoff was last Wednesday. We have a limited number of weeks until handoff, so